We are starting chapter 4 today. This chapter is going to take us through pretty much all of third quarter. We are splitting it up into multiple chapters within that. So our first chapter is going to be starting at 4.1 and going through 4.3. To kick off 4.1, we're going to see a lot of very familiar things. If you know and remember these well, you don't need to write anything down. For example, if I were to hand you a triangle with 2 out of the 3 sides, would you be able to find the third side for me using Pythagorean theorem? Okay, that is not new. We will use that a lot, and I'll expect that you can get me an answer pretty quick. Just a reminder on the 2 different things that can happen here. On this one, I am given 2 legs. So I would have 2 squared plus 3 squared equals x squared. In that case, I would add 4 plus 9 and square root, right? Over here, when I do that, though, my unknown is a leg. So instead of adding the 2 together, we would subtract 64 minus 25 and square root. Okay, so sometimes we subtract, sometimes we add the sides, whatever. Just slow down enough that you can know whether to add or subtract the sides. Okay, here's my next reminder for you. Dealing with radicals, kind of 3 different topics along radicals. Remember when simplifying, and we're going to do a lot of simplifying of radicals. Find your biggest perfect square. Start at half, right? I've got these up here. I'd start at half. 40 is about here. I would test out all the perfect squares on my way down until I found the biggest. Why do I do that? Well, as if I looked at 80, I would think 4 and immediately. 4 is not the biggest perfect square that goes into 80. 16 actually is, and I would find that first if I started at half and worked my way down. The other reminders I have for you with radicals are when dealing with fractions. I use the terminology inside and outside. That's just my own words. But if you were to look at that, can you identify what would be inside numbers and outside numbers? Like the 20 is inside and the 2 and the 12 are outside. When you're simplifying, make sure that you simplify numbers that are alike. If they're both inside or they're both outside, like the 2 and the 12, both outside numbers, I could simplify that fraction. Both are divisible by 2, right? But don't forget, just because it's inside the fraction, square root of 20, doesn't mean that it can't be simplified also. Square root of 20 actually is divisible by a perfect square, right? 4 goes into that. So we'd be looking at 2 square root of 5. You could have done that up here as well before we simplified the outside numbers. It would have saved you a step, actually. But make sure you get completely simplified. 2 and 6 are both divisible by 2, and we'd end up with square root of 5 over 3. My last reminder to you with radicals is if we have a radical in the bottom of a fraction, we have to use that fancy math word called rationalize, right? Remember that word? That when I rationalize, I want to multiply by what is inside that radical, square root of 15, top and bottom. Now, that's an outside number, that's an inside number, so they cannot multiply together. They just sit next to each other. But the reason I pick square root of 15 is for the bottom. Square root of 15 times square root of 15 is 15, right? Square root of 225, which is 15. Check your outside numbers. 10 and 15 are both divisible by 5, which would give me 2 square root of 15 over 3. Tempting to simplify there, right? The 15 and the 3 do have something in common, but that's inside, that's outside, cannot simplify any further. All of that's going to show up, but it should be a review. Any questions? Okay, my last little bit of review for you is a trip back to geometry. In geometry, you guys actually were introduced to trigonometry, which is where a lot of the beginning of this semester is going to look familiar. When you learned how to do right triangle trigonometry, just a couple of reminders. It was, you needed to pay attention to which angle they were basing the question off of. Now, up here you guys see a symbol that is going to be very common to us that you may not have seen before. It's a Greek letter theta. When dealing with trigonometry, theta is used a lot. It's a variable. It's the same thing as x or a or whatever letter you want to use. And if you don't like writing theta, don't. Write x, write a, I don't care. It's just a variable. But it tells us that we are basing our thought process, our side labeling off of this angle right here. You have 3 sides in this triangle. One of them's opposite, one of them's adjacent, one of them's hypotenuse. Let's start with the hypotenuse because that never changes. That is always the side across from our right angle. What do you guys know always is true about your hypotenuse? Biggest side, right, is always our longest side, okay? Now our other 2 sides are going to be forming the angle or across from the angle. And that will change based on where your angle is. If it is the other side of your angle, the one forming it, it's called your adjacent side. If it's one all the way across the triangle from that, it's called your opposite. Now, if I were to move where theta was located, my hypotenuse does not change. But now my adjacent side moves here and my opposite side moves here. So it is completely based on which angle we are talking about. And that is based on how they write the question. Okay? That's all my reminders for you to start. Any questions? In our trip back to geometry, you guys learned a mnemonic device back then to remember the first 3 trig functions. Does anyone remember the mnemonic device SOHCAHTOA? A lot of geometry teachers use that. Okay? It's not changing. I'm still going to say SOHCAHTOA a lot this year because that will remind us of those first 3 trig functions. Guys, there's actually 6 trig functions. This is where we want to start our notes. Okay? So this is new. We probably have never been introduced to cosecant, secant, and cotangent. The left-hand column we know, and hopefully we know well, sine, cosine, and tangent. Okay? Sine, cosine, and tangent, and our other 3, cosecant, secant, and cotangent. Trig functions are this. They are the ratio of 2 sides of a right triangle. And the interesting thing about right triangles is this. If it has a, let's say, 32-degree angle, let's say theta is 32 degrees, it doesn't matter if my triangle is this big or my triangle is this big. When I set up the fraction of the sides around that 32-degree angle, those fractions will be the exact same fraction regardless of how big my triangle is because of the properties of a right triangle. Now, these just tell you which of those fractions to set up. The ones we know, sine, cosine, and tangent. These are the actual words. Today's about the last time you'll ever see those words written out completely. But you guys learned a mnemonic device probably to remember the ratio of the sides around those. Sine, so, S-O-H. Cosine is A-H-C-A-H, so ka. Toa. Guys, I'm a terrible speller, and I don't really care if you spell words right. If you don't know how to spell hypotenuse, that doesn't bother me. But if you can't spell SOHCAHTOA, it doesn't help you. Okay? So that's like one of the few things you actually have to spell correctly in here. SOHCAHTOA. Okay? Now, what is that telling us? That's telling us that when we set up the ratio of sine, it is your opposite side over your hypotenuse. So if I were to label this triangle over here, opposite, hypotenuse, adjacent, that sine would be the ratio of the opposite number across over the hypotenuse number. Now, that's the word sine. If you look at your calculator or any problem you're going to see after this, sine will be abbreviated S-I-N. We are going to walk out of here and sound like intelligent math students and look at S-I-N and read it sine. And if you say the word sin, you are going to follow that up with, your math teacher is Mr. Brown. You guys all got that? Okay. If you say sin, your math teacher is Mr. Brown. All right. So sine is opposite over hypotenuse. Guys, when you are asked to set these ratios up, you're literally just doing a fraction. There's nothing to type on our calculators. It is a fraction. When we set them up, they're going to look like a fraction. Our calculator will tell us a decimal. Cosine. That's the word cosine. It is abbreviated C-O-S. And if I say the word cos or cos, my math teacher is Mr. Brown. All right. Getting the hang of that? Okay. Because I'm going to look at this and say cosine, right? Because I'm an intelligent math student. Cosine is your adjacent side over your hypotenuse. Tangent. Abbreviated T-A-N, red tangent, is your opposite over your adjacent. Now, in SOHCAHTOA, the order that they give us those goes numerator, denominator, okay, top over bottom, just like it looks. Now, if you know that mnemonic device, you know those 3, you feel comfortable with those, you guys it's really easy to know all 6 because all the other 3 are the reciprocals of the 3 we know. You just have to remember which one goes with which. Cosecant. First of all, this is going to take some practice. Cosecant is abbreviated CSC. So we're going to see CSC. We're going to read it as cosecant of theta, and we are going to have to remember that it is the reciprocal of sine. So sine is opposite over hypotenuse. Cosecant is hypotenuse over opposite. If I have this answer, I have this answer by just turning that fraction upside down. Secant, there's the word secant. It is abbreviated SEC. Okay, it is the reciprocal of cosine. So turn that fraction upside down, hypotenuse over adjacent. Cotangent, there's the word. It is abbreviated COT. Turn tangent upside down, adjacent over opposite. I don't have to memorize these. I just have to remember which ones they go with. Now, here's the thing that is frustrating. Apparently, they did not feel the need to ask me hundreds of years ago when this was all figured out. But I really don't think these match up well. I felt like cosecant should go with cosine, but it doesn't. And I felt like the one that started with S should go with the one that starts with S, but it doesn't. And maybe that's how you remember it. They don't go with the one you think it should. I have not found a better way to figure, like, to match them up. So you just got to remember. Or remember that they don't go with the one I want it to go with. The only ones that go together that seem like they should go together are tangent and cotangent. Okay. If you come up with a better way of remembering which goes with which, I would love to know. Cosine and secant have the same amount of letters. That works. There you go. If that helps. Same number of letters, same number of letters. Those two go together. There it is. Okay. Whatever you got to do. You got to remember which one goes with which. Take that fraction and turn it upside down, and you know that answer. All right, so getting used to this, we are going to just set up these ratios as we look at a triangle. If you realize you took wrong notes or you're not sure or whatever, this is what it looks like in your book. You can go to that page in your book. It's got them all of it listed there for you as well. Here's a very basic example to get us started. One thing we need to talk about in the directions is this. It says find the, and then we've got this phrase, exact values. Guys, you are not allowed when it says exact values to get decimal answers for this. Okay, we are going to simplify radicals. We are going to simplify fractions. Always. When we start problems like this, they will give us enough information, but probably not all information. Why they can't just give us all information? Who knows? But they probably won't. Notice, they give us 2 out of 3 sides on our triangle. Take us back to page 1 of our notes today. That means I do what to find the third side? You got it. So that's where we will start this problem. Start almost all of our problems, very honestly. Start with your Pythagorean theorem to find your missing side. And I think this one turns out nicely. What's our missing side here? 25. Okay. The next thing is this, is I want you to look at which angle they're asking you to write the ratios for, and that's written in the problem itself. Sine of A, cosine of A, they are all going to be the same angle in these problems. It's asking us for angle A. And what I want you to do is go to your triangle as you're getting used to this and label your opposite, adjacent, and hypotenuse. Okay. So in our picture, if A is down here, here's our hypotenuse, here's our opposite, here's our adjacent. And again, as I'm getting used to this, I can just sit my little chart next to me and set up those ratios or think through SOHCAHTOA, whatever it is. For example, sine, if I think through my SOHCAHTOA, right? Sine would be my opposite side over my hypotenuse, or 7 over 25. Guys, that's your answer. There's nothing to push on my calculator. Actually, the only thing I could probably use my calculator for is type in that fraction and make sure it's simplified. Other than that, you guys figure out the other 5. And you are welcome to look at your table partners and make sure you agree, because you guys are giving me the answers for pretty much the rest of today. right. Cole, I'll take cosine when you've got it. Good. Jonathan, tangent. As they're giving me answers, your job is to finish yours up and check my work here. Yes. Yes. Ooh, good question. I do not. They usually want it just as comparing two sides, so we'll always just don't do too much work, just do it, leave it improper. Sailor, since you said that, how about cosecant? Good. Seth, secant. Nick Wageman, cotangent. 23 or 28. I don't think they have anything common. And leave it improper. Yeah, leave it improper. Remember, once you get that first column done, you pretty much have the second column done. All I'm doing is flipping those upside down as I move to the next column. Any questions so far? That's a very basic example. Let's look at how this could take one step a little bit more difficult here. So same directions, same start. You guys start with that Pythagorean theorem to find your third side, please. Before we move on to the trig functions up there, let's make sure we all have the same third side. $385. Okay, so I would start at half, and I would work my way down, testing out all the perfect squares less than 385, and not find any. Okay, so I'm going to stop you if you're still typing in numbers here. There aren't any, and there's not guaranteed to be any in there. And if there isn't, it just stays the square root of 385. Remember, no decimals, because it said the word exact. That exact means simplify radicals, simplify decimals. Okay, so label your opposite adjacent hypotenuse and start setting up your trig ratios. I'll give you a second to work ahead of me here before I start getting answers from you guys. Nick Peterson, when you have sine, I will take that from you. Lily, how about cosine? Okay, Jordan, tangent? Ellie, how about cosecant? Okay. Peyton, secant? Good. And Tanner, how about cotangent? All right. Well, they kind of caught what I was hoping to talk about on here. Do you guys know what I'm talking about? Originally, flipping this one upside down would have left us a radical in the bottom. So if you had started with 24 over the square root of 385, you are totally on the right track. You have done the right move. You did the reciprocal. They just caught it. Both of you guys, good job. And they rationalized, right? So that was kind of the point of this one, is that's going to happen if you have a radical as one of the sides of your triangle. At some point in setting up your 6 trig functions, 1, 2, maybe 3, depending on which side it is, are going to have radicals in the bottom of that fraction, and you will have to rationalize to finish out simplifying. Any questions? Okay, we're going to shift to a similar problem, but it's going to start looking very different. On the last page, it asks us to find the 6 trig functions given a picture of the triangle. In this one, it says, if the sine of theta is 1/3, find the exact values. There's that phrase again that says we have to simplify our radicals and simplify our fractions of the 5 remaining trig functions of the acute angle theta. So we have 6 trig functions, right? Sine, cosine, tangent. And now the 3 new ones that we just learned today, cosecant, secant, and cotangent. And they asked us to find 5 because they told us one of them. They say that the sine of theta is 1/3. Go find the other 5. Now, my suggestion is, I found it really easy to have a picture to look at, so I could kind of reference back to my picture each time. I would do that again, is I would come in here and I would draw myself a triangle. It makes no difference. I tend to always draw my triangles the same way out of habit. But name one of these 2 angles theta, and it doesn't matter pick which one. Name one of them theta. But my triangle doesn't have any numbers on it. Where am I going to get numbers? From sine. And sine is what over what? 1/3, and it's my side lengths of opposite and hypotenuse. So I know that the opposite side should be labeled 1, and the hypotenuse side should be labeled 3. So then I can come over to this picture. This would be my opposite, label it 1. This would be my hypotenuse, label it 3. And now we're back to the page we were just on before this. I have 2 out of the 3 sides. Do my Pythagorean theorem and find the 3rd side. Set up my other 5 trig functions. Questions so far? Okay, now, if you cannot jump from here to here, you don't have a lot of hope of getting these. Now, you should get one of them. Which one should we automatically get? The reciprocal one, right? You better get that one, even if you can't draw me a triangle. You should get its reciprocal. But if you can't draw the triangle, you're going to have a hard time getting the others. Okay, so let's go ahead and find our missing side here. 1 squared plus whatever we want to call that. Okay, now I actually have the square root of 8 written up there. What's actually the side length? 2 square root of 2. Simplify all. If you don't catch that square root of 8 is simplifiable, your fractions are going to end up not being simplified because you won't have the right outside numbers to simplify with that. So it's actually 2 square root of 2, right? That can break down. Okay, now I have all the sides. Go ahead and fill in the other 5 trig functions, please. You can borrow one of mine. Ooh. All right, Sydney, I'll take cosine when you've got that. That's all right. McGuire, how about tangent? Okay. Cosecant. Who have I not heard from? Alana, how about cosecant? Okay. Secant, Kenzie? Yes. 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 Good setup, right? We need to keep going. Okay, which probably impacts your answer then. Yes. Very good. Okay. Yes, we're going to come back and simplify that guy, but I kind of like that we have it that way too as I move to cotangent here for a second. Brogan, what's our cotangent then? Okay. Now, several things to talk about. First of all, yes, good setup. We need to keep going. And now I like that we have this here because I'll tell you two things. First of all, there are two numbers down here. When I am rationalizing, I really only need to use the inside number, the square root of 2. So I multiply this one top and bottom by square root of 2. 1 times the square root of 2 is just the square root of 2. And then this is what always throws people when there's an outside number. That outside number is still there times the 2 we get from 2 square root of 2 times 2 square root of 2. And that's where 4 is coming from. If you look at that triangle, you don't see 4 written anywhere on it, but that's where that came from in that ratio. Okay, it seems like it kind of came out of nowhere. It came from rationalizing here. With that being said, when I go to do my reciprocals, guys, I would reciprocal the unsimplified version. If you reciprocal the simplified version, you'll get the same answer, but you'll have to do a lot more simplifying. If you go back to this guy and turn it over, no simplifying to be done. Okay, so that's a little trick. Anytime you're going to have a radical that's going to show up in the bottom of your fraction, use the unsimplified version to reciprocal it. Just save you some work. Okay. My next thing is this. Any questions on these answers? Okay, can we talk about the cosecant and the cotangent? Do you guys see how they have a denominator of 1? Not wrong. Your book, your problems would never put the 1 down there, would they? But it really is there. So we started this problem with this. What if we had started with cosecant? They actually would have said it was just 3, wouldn't they? And then you're like, well, I'm supposed to have 2 sides from that. Put it over 1. Anytime I need it to look like a fraction, I put it over 1, and now I have the hypotenuse over the opposite, right? So that's going to happen. I promise you that's going to happen at some point. They'll give you a whole number, and you need to make it look like a fraction to get both sides by putting it over 1, okay? Any questions before we move on from this topic? All right. Now we're going to move into our calculator and not exact answers. So we're going to get decimal answers here. I will tell you from here through the rest of this chapter, it's pretty much a rule of thumb. If you're talking a side length, it'll be to the nearest tenth, and an angle measure, a degree, it'll be to the nearest whole degree, whole number, okay? When we are setting this up, we are going to still look at labeling our problem, but you're going to think through SOHCAHTOA. I know you just learned 6 trig functions. Your calculator does 3 of them, so we will just narrow it down to sine, cosine, or tangent. Our job to start this problem, in order to find the value of x, the length of that side, we have to identify which trig function we're looking at. So what I want you to do is highlight for yourself which angle is in that picture. And if our sides that they have highlighted is either numbers or variables, are opposite, adjacent, or hypotenuse. Okay, so let's go ahead and do that. In this picture from the 35, Sailor, would you say the x is opposite, adjacent, or hypotenuse? Adjacent. And Cole, is the 7 opposite, adjacent, or hypotenuse? I feel like you just gave me all the options.
I thought you said is an opposite or adjacent to the hypotenuse.
Oh, no. Is 7 opposite, adjacent, or hypotenuse? Okay. All right. Once you have identified what sides we're looking at in there, you're going to think through SOHCAHTOA. And in one of those 3 options, you have just identified what we're looking at here. Adjacent and hypotenuse. So as I scan through here, here's the one that uses both adjacent and hypotenuse. That's how I pick which trig function to write my equation as. Questions on that? So it is cosine. So I set this up, and it will always say my trig function followed by the angle measure. If they tell us the angle measure, I put the number in there. If that's my variable, I put that there. They told us it's 35 degrees, so I write a 35 here. On the other side of that equal sign, I'm going to set up a fraction that is that ratio. adjacent over hypotenuse. Okay, so my adjacent side we said was x, over my hypotenuse we said it was 7. Now, before I finish this problem, guys, you're going to see this problem 3 times. There are 3 places that you can have a variable. In the top of your fraction, in the bottom of your fraction, or as the angle measure. So we're going to do one of each. Okay, so here is your one example of your variable being in the top of the fraction. To solve, if the variable is in the top of the fraction, right now I want x by itself. It's being divided by 7. The opposite is to multiply by 7. Okay, that would get rid of this. Now, here's my little helpful hint. When you type this in your calculator, I always suggest putting the 7 in front of cosine. If you don't, make sure you close the parentheses after the 35 before you hit times 7. Remember, if your number seems super weird or negative or something, we obviously don't have a negative side length. You're probably in the wrong mode. We should be in degree mode. How do I know it's degrees? Because it has the little dot for degrees after it. Okay. And then as you guys are typing that in, because this is a get to know our calculator moment, make sure we all know how to type this in correctly. I can tell you right now, I don't know what the answer is, but I know it's something less than 7. How do I know it's something less than 7? Hypotenuse has to be my longest side. So that's a good indication that I turn my fraction upside down if I get something bigger than 7. That's probably what happened. What is it? 5.7. So we're going to pause here. Is everyone getting 5.7 when they type in 7 times cosine 35? Okay. That's your one example where the variable is in the top of the fraction. You multiply by the bottom of the fraction. All right, let's move on to our next one. Again, we're going to identify where the angle is in here. They put a 41 right here, so we'll use that guy. Okay, so let's label our sides here. Jude, is the 7 opposite, adjacent, or hypotenuse? Jonathan, x, opposite, adjacent, hypotenuse? Okay, so based off of those options, Sydney, would you pick sine, cosine, or tangent? Good. We have opposite and hypotenuse. That tells me to pick sine. I fill in the angle measure after sine, which we actually know on this one is 41. Okay, and then we set up our ratio after that. Peyton, is it going to be x over 7 or 7 over x? So this is our example where the variable is in the bottom of the fraction. I'm going to show you the algebra behind it, but then we're going to speed it up because it's going to happen the same way every single time. If I were to show all my work algebraically, to clear the variable out of the bottom, I would start by multiplying both sides by x. And it's x times this number, times sine of 41. And I, again, want x by itself. So I would divide both sides by sine of 41. And I get to x equals 7 over sine of 41. Type that in your calculator. X is my hypotenuse. Biggest side. I should expect something bigger than 7. It's a side length, and for this entire chapter, side lengths are going to be rounded to our nearest tenth. 10.7. So let's speed this up. If my unknown is in the bottom of the fraction, you're going to divide by the trig function. It kind of looks like the x and the trig function just swapped spots. They didn't, but that's kind of what it looks like happened. When it comes from the bottom, your variable's in the bottom, you divide by the trig function. If your variable's in the top, you multiply by the trig function. That's your two options. Okay. What if our unknown is the angle? If our unknown is right here inside of the trig function, okay, I get it. Cosine is squished up next to a, isn't it? And usually squished up next to means multiply. It is not cosine times a. That is a function being applied to that number, okay? Similar to the idea, if I were trying to solve a function that said something like x squared equals 25, to undo the square, I would do its opposite, which is square rooting, right? I have to do the same thing over here. The opposite of cosine is what's called inverse cosine. Now, this is the last time you'll ever see me write it on both sides, but if I were to do the inverse cosine, I would do this to both sides. I don't write it like that, but those two are canceling, and I get a left over. So this cosine raised to the -1 is the opposite of cosine, the inverse of it. It undoes that function. So if you guys will grab your calculators, look above the button that says cosine, you'll see cosine raised to the -1. That's what we'll use to solve for an angle, inverse cosine. So hit second cosine. Let's go ahead and just use this one as an example. 3 divided by 5, or 3/5. Doesn't matter how you type it in. This entire chapter, we will always round angles to the nearest degree, nearest whole number. So the inverse cosine of 3/5, I don't know what that is, 53. Okay. All right, now let's look at a picture where we actually have to get that from the picture itself. Similar, we set it up the same way. You identify where the angle is, and then we from that identify what sides we're looking at, opposite, adjacent, or hypotenuse. Okay, so theta is here. Gavin, would you say 12 is opposite, adjacent, or hypotenuse? Okay. Dylan, 15.7, opposite, adjacent, or hypotenuse? Okay. Alex Downing, sine, cosine, or tangent based off of that. Okay, this is the first time we've seen this where after sine, I'm supposed to put in the angle measure, but I don't know what that is. It's my variable, so I put my variable there. Whether it's the variable theta, maybe they called it a, I would put an a here, but that's where the variable goes. Okay, and then I set up my function, or my ratio on the other side, opposite over hypotenuse, and I use my inverse function to solve for theta. Theta equals, that sine looks like it slides to the other side, but it is the inverse sine of 12 over 15.7. Type that in my calculator, round to the nearest whole number. I don't have a calculator, so you guys have to let me know when somebody's got it. 50? All right, any questions? Yes?
Do you want us to show those steps in our homework, or can we just automatically do?
You do not need to show those steps. Nope. All right, last type of problem. The last type of problem is going to fall under the heading solve the triangle. Due to our time constraints today, I'm going to talk through this very fast. Please be on your calculators quickly and get me numbers here. Are you ready? There are only two ways that you can see solve the triangle. One will look like this. When it says solve the triangle, first of all, there are 6 parts to a triangle, right? 3 sides, 3 angles. When they ask you to solve the triangle, they will give you 3 of those things. You find the missing 3. One of the ways that that can be done is giving you a right angle and 2 sides. Okay, the other way is a right angle, 1 angle, 1 side. That's the only 2 ways this can happen. So let's go back to this one. If this is how it starts, the very first thing I would do is Pythagorean theorem to find my missing side. Notice we are still under the heading of round to the nearest tenth for a side, nearest degree for, go to my nearest tenth on that. Okay, 1 out of the 3 things we need. We need an angle. It doesn't matter. I need angle C, I need angle A. I don't care which, but we are going to use inverse trig to find an angle. Maybe we're finding angle C. I would use the 2 exact numbers they gave me. I would not use the 31.1 because that's rounded and can impact my next answer. It's not a rule, but I would stick with the exact numbers. Okay, so that would be my adjacent and my hypotenuse, which means I would use cosine, which means we're using inverse trig. So angle C is going to equal the inverse cosine of 20 over 37. Rounded to my nearest degree. Who's got that for me? 57 degrees. Okay. And the last one. Guys, I can do my inverse trig again, but what do you know about triangles? They equal 180. So subtract. You know 2. So 180 minus 90 minus the angle we just got gives me angle A equals what? 33? All right, that's one option. Second option, they give us, and I can go back to this so you guys can take a picture or finish notes or whatever. There it is. They give us one angle, the right angle, and one side. If that's the case, you start with that whole 180 thing. So subtract from 180 to get your angle. So 180 minus 90 minus 23 equals what? 67 degrees, angle T. And then we have to use trig to find our missing sides. Okay, pick a side. It doesn't matter. So if I were picking side S, that would be adjacent and hypotenuse. I would use cosine. And we do that again. SOHCAHTOA again. So if I'm finding side R, that would be opposite and adjacent. I would use tangent. Now, technically for step 3, you absolutely could use Pythagorean theorem, but then you're using a side that you rounded. Usually will not change your answer. It does have the potential to impact your answer. Show your work and you're fine. Okay, so if you really like Pythagorean theorem over trig, you can just show your work. All right, your assignment is a whole bunch of just random numbers on page 227.